Now, once we understand this basics, let's focus on fundamentals of machine learning, because machine learning is a very important part of artificial intelligence. Let's start with a simple question. What is machine learning? Well, machine learning definition says that it's going to create predictive models by finding relationships in data. So technically, you are going to provide a training data, which is going to be generated based on some past observations. It can be in any format, structured, unstructured, semi-structured, and then most of the time this data is going to have some particular labels associated with that. Once you have data with labels, you can ingest the data into your machine learning system, where you're going to have multiple algorithms which can help you to generalize finding relationship between data, and also it is going to help you to classify and categorize the data. When this happens, these algorithms are going to process on that particular data, and using that they are going to provide something which is known as model. These models are going to have a data which is processed inside that. This model is generated as a result of these algorithms. Whatever calculations, whatever logical executions which you have done on the data, based on that this particular model is created. You have to come to the training model kind of a phase where you're going to provide data, you're going to divide data for different kind of a task like prediction or inferencing data and all, and then after that you're going to have a trained model associated with that. Now if you ask me what kind of a model training is going to happen, well, that depends on what kind of a machine learning you're using. You can see right now we have some types of machine learning visible in this particular hierarchical structure. We have supervised and unsupervised machine learning. As you can see in this diagram, supervised machine learning is going to have a training data which is including unknown labels in that. So we exactly know what kind of data we are ingesting in that. While unsupervised learning is not going to have a data which is labeled. So it's going to have an unlabeled data inside that. Mostly unstructured, unlabeled data will be there in unsupervised learning. Same way here in supervised learnings, you can have algorithm for regression, you can have algorithm for classification, and based on that you can process the data which will help you to predict maybe a number of ice cream sold by a particular company on a particular date, or maybe in a particular season. And maybe if you can use a classification algorithm, you can do binary classification or multi-class classification, where you can identify a particular object, particular details about a patient of a medical history. It depends what kind of classification you want to do in that. In the other hand, if you're using unsupervised learning with unlabeled data, then maybe you're going to use clustering kind of algorithm, which is going to group similar kind of items based on that. It can do separation of the plants into a group based on the common characteristics which are visible in those plants. Now, which algorithm you're going to use for your machine learning, what kind of data you're going to provide in that, this is something which is always going to change. And that is what a machine learning engineer is going to decide. But remember, if your model training is proper, if your machine learning is going properly, then only your AI applications can give you a perfect organized result. Now, how exactly this model training is working and how it can evaluate inside that. Let's focus on that. As you can see here, we have 1, 2, 3, 4, 5 steps here. Each step is showing you what exactly machine learning and model training is going to do. Step number 1 is we are going to split the data into training set and validation set. Mostly it's going to be 70-30 or 80-20 kind of a ratio, where we are going to use 80% of data for training, or maybe 20% of data will be used for validation, so that we can check whether the model training happened properly or not. In step number 2, we are going to apply an algorithm to fit the training data into that particular model. When this happens, we have to provide a proper algorithm. Then only the model training will happen properly. Suppose if the model generated from particular algorithm is not proper and not giving me executed proper output and predictions, I can change the algorithm and I have to retrain the model. Step number 3 is going to give you a trained model encapsulated the relationship in your data. So when you have provided your labeled data, it is going to create a relationship between them. And this is going to be a much more organized data in step number 3, and that's why we call that model. Step number 4 is going to use that model, which is generated based on step number 3, and is going to generate predictions from the validation data. Now, this step number 4, which is going to generate predictions based on the validation data, can be having issues inside that, or it can be proper. This is something which you can do based on the evolution, and that's the reason step number 5 is there, where we use evolution metrics to compare the predicted data versus actual labels which are supervised in that, or maybe the measure cluster separation kind of thing which is happening with the unsupervised data. Depends upon what algorithm you have done. These 5 steps you have to repeat again and again and again until unless you're getting a proper result from your model which you have trained. Now, there is one more word with machine learning which is equally important to understand, and that is deep learning. Deep learning is going to help you to understand how artificial neural network is designed and it is working. And as you can see in this diagram, we have something which is human neural network. It is actually something which is how your brain is wired. So every human brain is actually going to provide and process millions of neurons inside that. These neurons fire in your response of electrochemical stimulus. Whenever you're doing something, you are actually processing millions of neurons inside your brain. Based on the similar kind of concept, we have artificial neural network, which you can think like working like a processor or a human brain. Each neuron which is inside this artificial neural network is a function that operates on an input value, which we can count it like an X here, and the weight which you have given, which is W. The function is wrapped in an activation function that determines whether to pass the output on or not. Now, this kind of multiple neural networks connections are going to be there. Neurons are connected with network, and that's the reason we call this thing neural network. If you have heard about something called RNN, recurrent neural network, or if you have heard similar kind of neural networks when you have done some R&D with maybe GPT, chatbots and other things, then it's all driven by neural networks. Artificial neural networks are the brain of your AI, which is actually going to process the data, and if you have more number of neurons, then it means you can process more data in a much efficient way. Now, how the neural network looks like? If I try to understand and compare deep learning with machine learning, you can understand this diagram. In this diagram, each blue dot which you're able to see is actually a neuron, which is part of this neural network. Now, this is a very good example of multi-class classification using neural network. At left side, you can see that we are ingesting a data, which is actually having a penguin's image. Now, as a human being, we understand that. But every time when you provide this kind of a data, it's going to measure the image size, it's going to measure the features of that, the weight of that penguin's, the maybe characteristics which are there, what kind of wings he has. And then after that, this data is going to be provided with multiple vector graphics associations into this particular neural network. The neurons inside this neural network is going to process them. It's going to have multiple multi-layer loop inside that, which is going to process this data, like our brain is doing that. The label data and whatever features which are associated with this label data is going to process that. And at the end of this, based on the multi-class classification, maybe from the available categories of the image which we have generated based on the penguin's data which we have provided in our model training, it can classify that this penguin is matching with which kind of penguin. And then we can identify the breed and the other details of that. Now, this process of interfacing is something which is predicting the penguin class using the neural network. And same way, you can do any kind of a classification algorithm or maybe the other algorithms using neural network. In simple words, your neural network is going to be your processing engine, which is taking your data, comparing with the predefined model training which they have done, and then finding the perfect answer based on that. After all these concepts, now it's the time we are coming to a word which is Azure Machine Learning. Because we understood what is machine learning, what Azure is providing in that is very important to understand. As you can see in this slide, we have right side one particular Machine Learning Studio screenshot. This is showing you that we have a separate workspace where we can actually use machine learning algorithms, we can label our data, we can ingest data, and then we can do the model training. Once model training is done, we can also visualize the metrics associated with that, whether the performance of that model training was proper or not, what kind of AUC curve is achieved with the help of this, what kind of confusion metric is there, whether my models are able to give me results which are properly predicted based on the model data or not. This is all provided in your machine learning studio, because this is a user interface for accessing your machine learning capabilities. All these features will be provided where you mostly have to do drag and drop customizations, and you can use Azure Machine Learning Studio. If you're planning to be a machine learning engineer, this is going to be your work area where you are going to create machine learning with maybe different kind of Python or different language based notebooks. You're maybe going to automate machine learning using automated ML, or maybe you do not want to write a code and you want to use Machine Learning Designer, which can just help you to design the machine learning algorithm by just dragging, dropping and customizing things on the designer surface. There are a lot many things inside that, but because this course is very fundamental course, we are not going in depth in Azure Machine Learning. Now we have Azure Machine Learning and couple of other demos associated with this course. As I have mentioned earlier with you, that if you are trying to get maximum from this course, then this link is going to give you all the exercises. As you can see, we have a first exercise which is exploring automated machine learning in Azure Machine Learning. During this course, whatever demos, whatever labs which are associated with this is all going to be listed here. But remember, this link is going to give you all the steps. In order to execute these labs, either you need your own Azure subscription where you can create Machine Learning Studio and you can configure that. Or if you do not have an active Azure subscription, we are partnered with Scalable. Scalable is actually going to provide a lab for each and every Azure course. As you can see, this is AI 900 course lab, which is going to provide a cloud slice with all the instructions inside that. If you want to use Azure AI labs, and if you want to get certified in Azure AI 900, we strongly recommend that you should do the labs practically. This Scalable lab is going to provide an interactive lab simulator where you're going to have a separate machine where you can directly have all the instructions which you need to perform, and it is also going to give you a cloud subscription which is known as Cloud Slice for a limited period of time for few hours in which you can complete the lab. This lab environment is going to take you through all the instructions, and the awesome thing is you don't need to install anything in your computer. You don't need to give any credit card information. Without giving any of your personal details, you will be able to use this lab environment, which is going to be ready in few seconds. How the lab environment looks like, I'm going to show it to you right now. We are not going to use this lab environment during this course, but I strongly recommend after understanding each and every concept, you should do the practical labs, either in your subscription or by some kind of a lab provider where you can get this. If you want this kind of a lab, you can reach out to us. We can provide this kind of a lab as we are partners with Scalable, but these labs are going to be chargeable basis, so you have to pay the fees according to the lab environment which you're choosing. Now, as you can see, my lab environment is loaded, which is always going to have two different sections. The left side one is a virtual machine kind of a computer where I can log in and I can provide the details, like it's giving me the password here. I can provide the password. I can log into that computer, which is going to be my lab environment. And then right side, you can see they are giving me an Azure subscription with something which is known as Cloud Slice. I can open browser in this lab environment. I can log into this particular username and password. And then once I do that, my Azure subscription will be available with all the Azure AI services and machine learning services with that. All I need to do is I need to go to maybe a browser. Let's open that. I'll open the Azure portal, which is portal.azure.com. And once I open that, I have to provide these credentials. These are dynamic credentials generated for the limited period of time. As you can see here, this lab is going to take around 1 hour. So this Cloudflies is going to be available for you for 1 hour. You can sign in. Your subscription will be available immediately. Like this. And now all you have to do is you have to just go through these steps which are mentioned in the right side instructions. These steps are also super easy to follow kind of steps. When I go to Azure subscription, they are showing me first I have to open my cognitive.azure.com kind of content safety, and then I have to sign in with that. Then they are showing me I can go with different studios of Azure AI, where we have Speech Studio, Language Studio, Translator, Vision Studio, Form Recognizer. All these are actually those AI workloads which we can use with Azure AI services. I need to follow the steps. I need to do the configurational things which they are mentioning inside that. And once I'm done with this, I'm done with the lab. How easy it is. It is always like that. But yeah, once I'm done with this, I can just end my lab. I can say yes, end. And then this is going to be killing that particular session, and I can proceed to my next lab. With AI 900, this kind of multiple labs are there. You have total 6 different labs with 1 hour durations and all. And then you are going to have some practical assessments at the end of this. We strongly recommend if you are going for a certification exam, you should do these labs. And even if you're not going for certification exam, you should try the labs with your own subscription or with the lab environment, where you should understand how to write a logic associations, what kind of things we can do with image analysis, face detection, or maybe we want to do something where we want to explore Speech Studio and we want to generate an output which can be giving me an output in a speech format with different voices. All these customizations are very interesting and very important to learn.